Hello dear friends, welcome to the lecture of geometry. Solid geometry we are studying, or solid analytical geometry we are studying, and we are studying the chapter plane. Last time we have obtained this formula. This is a recap or revision that we have done in last lecture. We have obtained the length of perpendicular from the point P x1 y1 z1 to the plane Lx plus My plus Nz is equal to P. So this plane is in normal form. We know this is the normal form. And that length of perpendicular between these two is given by this simple expression, absolute value of Lx1. So that means we have to put these coordinates in the expression of the plane. And that gives absolute value of Lx1 plus My1 plus Nz1 minus P. That we have studied. Now in this lecture we will study how to find the length of perpendicular from the same point P to the plane which is in general form. See, here it is normal form, here the difference is it is in general form. And after obtaining this formula, we will solve some problems from the exercise. Now, how to obtain the length of perpendicular from this point to this plane? So, we will make use of this result, earlier result. And how to make use of this result? To make use of this result, the plane equation of plane must be in normal form, and we know that how to convert the general form of equation of plane into normal form. So we'll convert this equation into normal form and then use the formula. So that's why this result is considered as a corollary. So we will write the normal form of the plane is the normal form of the given plane. Given plane means this now, or general plane is, we know the transformation of general to normal form. What is to be done? This coefficient of x, y, z are to be, and d also to be divided by under root quantity, summation of a square. And summation of a square means summation that is a square plus b square plus c square under root quantity. And the normal form of the given plane is, that will be plus or minus a divided by under root of sigma a square into x plus or minus b divided by under root quantity of summation a square into y, and so on. So this is the normal form of this plane. And the sign is plus or minus, that is d divided by, again, under root summation of a square is equal to 0. So this is thus we have converted this equation. We have solved the problems on this also, and it is easy to convert. That depends on which sign is to be taken. That depends on d is positive or negative. If d is negative, we take the positive sign of this, and if d is positive, we take the negative sign of this radical. That's why we have written plus or minus. And now we can use this earlier result. So what is the change is, in place of L, it is a divided by under root of summation a square. See, compare this with, this is the value of L, this is the value of M, and this is the value of N, and what is the value of P? This is to be transferred on that side, and that will be plus or minus becomes minus plus d divided by this. So therefore, using this result, we will have, thus therefore the perpendicular distance of the point to the plane is, therefore the perpendicular distance of P x1 y1 z1 to the plane is ax plus by plus cz plus d is equal to 0 is, and is equal to, we will write it in absolute value, because the distance is always positive, and therefore whatever the magnitude will be there, either positive or negative, that should be taken as absolute value, means positive value. And what we have to do is simply here how we have obtained this distance. This is the expression of a plane, equation of plane in normal form. Replace x, y, z by the coordinates x1, y1, z1. C. Lx1 plus My1 plus Nz1 minus P, and subtract this P quantity. And thus here that will be, this will remain the same. This is L, and in place of x we have to write x1. So the expression will be the same. Ax1 plus by1 plus cz1 plus d will be there, divided by under root quantity of this, and this is a common denominator, so we'll write that denominator as. So here are we can write where summation a square is equal to a square plus b square plus c square. That is the meaning of sigma a square. It is written in brief form, and thus this will be a into x1. Now there is no need to write plus or minus because we are taking absolute value. So that is a x1 plus b into y1 plus c into z1 plus d, the same. This d is written on the left side. This p is written can be written on the left side, then it is minus p. So minus p is taken as it is. So therefore we should take d as the same, divided by under root of the common denominator is summation a square, under root of summation a square. We will write its full form, and that is a square plus b square plus c square. And thus this is the formula for the distance of the point from the plane. And it is similar, only we have substituted the coordinates of this point over the expression of the plane, and that is divided by under root quantity of sum of squares of the coefficients of x, y, z, that is a square plus b square plus c square. And here it can also be taken as the same. If you divide it by summation of L square plus m square plus n square, but we know that these are the DCS, direction cosines, and the sum of squares of the direction cosines is 1. So the denominator becomes here 1. So both the formulae are similar, or actually this formula is general formula, and it is obtained from the normal form. So thus we have both these formulae. Now we will solve problems depending on this. Now for this normal form, it is a simple form. So if you consider a point as a say P point, and the normal form may be taken as 1 by root 3 times x plus 1 by root 3 times y plus z, and plus equal to p can be taken as 2. So this is of the form L into x, etc. And if I take the point as say root 3 root 3 root 3, then what will be the distance between this point and this plane? So if you use this formula, then the perpendicular distance will be between these is equal to absolute difference of. Now put these points here. So why we have taken 1 by root 3, 1 by root 3, etc. Because if the condition is to be satisfied is L square plus m square plus n square must be equal to 1. So this is 1/3 plus 1/3 plus 1/3, that is 1. So that's why we have to, when we write the equation of our plane in normal form, then these must satisfy the condition of L square plus m square plus n square is equal to 1. Then only it will be in normal form. Otherwise it will be in general form. And then what will be this? If you see, then this will be root 3 by root 3. Put the point x as x1 here. And if we have considered for simplicity the point as root 3, root 3, root 3. Any point can be taken, not only this. And thus this will be 1 plus 1 plus 1. And that is, and minus p is 2, so, and this is 1. So in this way we can use this formula. Now how to use this formula, that is again similar. Put the coordinates over this expression of the plane and divide it by under root quantity of a square plus b square plus c square. And this distance between point and plane, we know what is the distance between a point and a line. If in two dimension, if the point is x1 y1 and if the line is say ax plus by plus c is equal to 0. So what is the perpendicular distance we have is, put the coordinates on this line. This is the formula we have studied in earlier classes, and that perpendicular distance, this distance, if it is pm, then pm is equal to, put the coordinates here. this is the perpendicular distance of point and line. That is a into x1 plus b into y1 plus c divided by root of a square plus b square. This formula we have studied earlier. Now what is difference is in place of the 2 dimension we have the 3 dimension, and in place of this line we have the plane. And here, so the point is x1 y1 z1, and in place of ax plus by plus c line there is a plane. So that means this is the plane and this is the perpendicular. Say PM is the perpendicular, and for this point and the plane. Now what is the distance? See, this is ax1, this is the distance, a into x1 plus b into y1, etc. And thus the formula is similar to the distance between point and line in 2 dimension, and in this in 3 dimension point and the plane. Now we will consider the problems from exercises. So see the first problem. The first problem is find the distances of the point. 2 points are given and there is one plane. So we will write its solution. Solution for first problem. And we can use this formula. Generally the equation of plane will be in general form. Exceptionally or few cases it will be in normal form. And if it is in normal form, then also we can use the same formula. So this is important. This is the perpendicular distance of the point and the general plane. So this is important and we have to remember it. Now we will write first taking this point 2, 3, 4. The perpendicular distance of the point, and we will use this formula directly. The perpendicular distance. Distance here is to be always considered as perpendicular. Perpendicular distance of the point. The point is 2, 3, 4 from the plane. From the plane, it is 3x minus 6y plus 2z plus 11 is equal to 0 is equal to, or we may write is equal to, and compare this point and this equation of the plane like this. This is the point 2, 3, 4, that is x1, y1, z1, and this is the plane ax plus by plus cz plus d is equal to 0. So we have to put the coordinates in place of x, y, z, and that will be 3 into 2 minus 6 into 3 plus 2 into 4 and plus 11 divided by under root of a square plus b square plus c square. And what are the values of a, b, c? The coefficients of x, y, z. That is 3 square plus negative 6 square and plus 2 square. And this is the absolute value to be taken. And see the calculation for this. It is 6 minus 18. So 6 minus 18, and this is plus 8 and plus 11. So what it results, this is minus 18 and plus 14, so minus 4 plus 11, so that will be 7. So this is 7. And what about the denominator? Under root quantity of. So you should check the calculations, and this is 9 plus 36 plus 4, so it is 49, root of 49, and we know root of 49 is 7, so it is 7 divided by 7, and that is equal to 1. So this is equal to 1. So 1 is the distance between, perpendicular distance between the point and the plane. So in this way it is easy to use the formula. Now for the second point, see this point is there and you should try yourself. Answer is written here. The answer is 5 by 7. Try for the second point. Try yourself for second point. For point 114. The answer is 5 by 7. Now we will consider the second problem. Solution of second. So what is given in the second problem? Find the locus of a point. Find the locus of a point. Condition is the sum of squares of whose distances from the planes, 3 planes are given, and sum of squares of these distances is 9. And locus of a point means, see, locus is equation which satisfies certain geometrical condition. Equation of a point which satisfies this condition. And we take a point on the locus as x1, y1, z1. So write solution for second. Let P x1, y1, z1 be a point or be any point on the locus. And from the given condition, its distance, sum of squares, see the condition, geometrical condition we have to observe, sum of squares of whose distance from these 3 planes is 9. So therefore its distance from each plane we have to write and then take the sum of squares. So distance of P from the given planes will be or it is distance of P from the given planes or we have to write all the distances of P from these 3 planes. So x plus y plus z is equal to 0. Second is this one, and this. We have to use this formula, and exactly we can use the point is the same, x1, y1, z1. So these distances are this point is to be put as x1, y1, z1 over this expression. That will be x1 plus y1 plus z1 divided by root of 1 square plus 1 square plus 1 square, that is 3. So I shall write it directly, root 3. And second, the distance of this point from this plane, and that will be absolute value of x1 minus z1 divided by under root of 1 square plus minus 1 square. There y is absent here, so therefore that will be coefficient will be 0. And you know this how to use this. This is to be written in general form. This form ax plus by plus cz plus d. Here a is 1 into x, 0 into y, and plus minus 1 into z. Y is coefficient of y is 0 if y is absent, and thus it is simply this distance. And again from this point that will be, see, it is x1 minus 2y1 plus z1 divided by under root of 1 square plus minus 2 square plus 1 square. And so these are the distances, are the distances of P from given planes are these respectively. Now what is given? The sum of squares of these distances is 9. So by given condition, we have, so square it and add it. Squares is there. So if it's square, then there is no need to write absolute value because square is positive, and therefore squaring this, what we will get, x1 plus y1 plus z1 divided by 3. It's a square, whole square divided by 3. Square of root 3 is 3 plus it is x1 minus z1 whole square divided by what is the quantity is 1 plus 1 root 2, square is 2, and plus this is x1 minus 2y1 plus z1 whole square divided by this quantity is 1 plus 4, 5 plus 1, that is 6, root 6, square is 6, and this sum is given to be 9, is 9, sum is 9, sum of squares is 9. So this is our equation using the given geometrical condition. And now we have to simplify this and get a relation in terms of x1, y1, z1. That gives the equation of required locus. And to eliminate this fraction, we will multiply both sides by 6. And if you multiply by 6, then each term we have to multiply by 6. Here it will be multiplied by 6, so that gives 2 times this expansion. And we will at the same time we will write the expansion of these squares also. So multiply by 6 and write the expansion. So that gives, multiply by 6, it is 2. And in bracket I will write the expansion of this. Expansion of the square of 3 terms, sum of 3 terms. That is a plus b plus c whole square. And it will be x1 square. We will write first square terms. That is x1 square plus y1 square plus z1 square. And then we write the middle terms. That is 2 times x1 y1 plus 2 times y1 z1 and plus 2 times x1 z1. So this is the square of the first term. And plus we are multiplying by 6. So this is 6 divided by 2 is 3 in bracket. And expansion of this, that is easy, x square plus z square minus 2 x1 z1. And next, again the next term we have to multiply by 6, means this 6 cancels, and we have to write only the expansion of this square. And as like this will be write the square terms and then the middle terms. So it will be x1 square plus 4y1 square plus, that is z1 square, and then the middle term, this is negative 2 times first into second term, that is negative 4 x1 y1. So this is only the part of arithmetic simplification, algebraic simplification. And then the next product of these two, that is also negative 4 times y1 z1. And next is x1 z1 2 times, that is positive 2x1 z1. So this much is the expansion of this, and is equal to, we have multiplied each term by 6, so right side is to be multiplied by 6, and 6 into 9 is 54. So thus this is the simplification of this term, and further we have to write simplification. So I shall write here, and you see what it will be. See, we will add the square terms first, x square terms. So it is 2 times x square, 3 times x square, and plus 1 times x square. So it is 6 times x square. That is 6x1 square plus y1 2, and here there is no term of y1 square, and here it is 4y1 square. So 2 plus 4 is again 6y1 square. And plus, next what about z1 square? This is 2z1 square, and here it is 3z1 square, and here it is 1z1 square. So 2 plus 3 plus 1, that is 6z1 square. Next, we will write now the x1 y1 term plus, see how many terms are there. Collect the terms and write the coefficient together. So 2x1 y1, then what is next term of x1 y1? You may see 2x1 y1 further, and here it is minus 4x1 y1, but this 2 is to be multiplied by this 2. So 2 into 2, 4x1 y1, and this is minus 4x1 y1. That terms cancel. And what about y1 z1 term? You see, this is 2 into 2, that is 4 y1 z1. And what is the further term of y1 z1? Here it is minus 4 y1 z1. Again that cancels. 4 times y1 z1 minus 4 times y1 z1 cancel. And what about the remaining term? 2x1 z1 multiplied by 2 means 4x1 z1, and that is here minus 6x1 z1, and here it is plus 2x1 z1. So the 4 plus this 2 is 6, and this is minus 6. So that also cancels. All middle terms in the expansion cancels, and thus only the left side remains with these 3 terms, is equal to, what is the right side is 54. And thus we can divide by 6 now, and the equation of locus can be written in general form, replacing x1 y1 z1 by x, y, z, and thus therefore the equation of locus is replacing x1 y1 z1 by xyz and dividing by 6. The equation of locus will be x square plus y square plus z square is equal to 9. 54 is divided by 6, and this is the answer. So thus we have solved the second problem. Here we have used the formula between distance of point and the plane. First we have written the distances, then we have used the condition sum of squares of these distances is equal to 9. Simplify this and we got the equation of locus. Now what about the third problem? See, actually third problem I will leave you to solve. Now, but I will give a hint to you how to solve the third problem. What is asked in the third problem? Show that we have to show it there. Show that the distance between two parallel planes. Distance between the parallel planes. These are parallel planes. You may easily check because the DRS are in proportion. 2 minus 2 1, and here it's 4 minus 4 2. They are in proportion, and therefore the planes are parallel, and the distance between these two parallel planes is 1 by 6. We don't have the direct formula for distance between parallel planes. We have the formula between point and plane, but we can make use of that formula to find the distance between two planes. Now what can be done is, see, these are two parallel planes. For example, suppose these are the parallel planes, one over the other. These are parallel planes, and we want to find the distance between these two planes. So we may take a point, any point on the plane, and then we'll find the perpendicular distance of that point and this plane. This is suppose if it is PM, then that is the distance between the two parallel planes, these two planes. This is the distance. So thus it is easy to solve this problem. Take any point. So you may consider any plane as one and other as second. So or you can interchange. We suppose this as the first plane, and that is, its equation is 2x minus 2y plus z plus 3 is equal to 0. And the second plane is 4x minus 4y plus 2z plus 5 is equal to 0. This is the second plane. What we require is a one point from this plane. There are infinitely many points on the plane, and plane is also an infinite surface. So which point is to be taken from this? Take any point from the first plane, and that can be, select any value of x and y, our choice, and then determine z from this equation. We may select x as 1, y as 1. Then what will be z? You see, if x is 1, y is 1, then this is 2 minus 2, that is 0. And what remains? Z plus 3 is equal to 0, means z must be minus 3. So this is a point on the first plane. And then we can get the coordinates of this point as, say, 1, 1, minus 3. Not only this, so we can take the point more simple also. X is 0, y is 0. See, x is 0, y is 0. Then what about z? Again, this is 0 minus 0, that is 0, and z plus 3 is 0, means z is again minus 3. Because these points satisfy this equation. You can cross check. These points must satisfy the equation. So therefore these are the points on the first plane. Take any point, either this, or you can choose at your choice. There are infinitely many points. And find the distance between this point and this plane. That is the required answer, and that is, you can say, check easily. The answer is 1 by 6. So find the distance between this point. So take a point on one plane. Then the distance between two parallel planes is the distance between the point and the other plane. two parallel planes is the distance between a point on the first plane and the other plane and the second plane. So this much information need not to be written, but we take the point directly, first plane and the second plane. So we take a point. What point we have considered? 1 minus 1 or 1 1 only we have considered, 1 1 and minus 3 on the first plane. Then you may write directly the distance between this point and this plane is equal to, and show it is 1 by 6. So you can solve, you can write the remaining steps easily. So this is about how to use the, we have obtained actually the formula, distance formula between point and plane, and we have used that formula to solve these type of problems. So the remaining part we will continue in our next lecture. Thank you.